when it related to our negative or positive, which is sign number, isn't it? So sorry, I'm still not feeling well since last week. Okay, then we look several method, especially the most important I said last week, related to your multiplication, first version multiplication hardware, which is, this is a math question. It will be several set will be given at the set B, part B, which is part B, sorry. Part B, you're going to be given several set. Might be you will get multiplication hardware. Sometime your friend will receive the division hardware. So you need to remember the step. The flow chart will be given. As mentioned, the flow chart, normally it will be given this flow chart similar to your the division, but you need to know how to apply. What is this step? Sometimes you don't know. Multiplier 0, what is this mean? And where you going to put, which is MC is where? You cannot swap the value. But for multiplication, it's not critical. If you compare to the division, it's need to be followed exactly. And then where is the MP and product? And in terms of the table, you will be given empty table like this. You need to fill in at the correct place. If you are lucky, we will give you the drop down. If not, you need to fill in by yourself. Okay, the value. I still remember last 2 or 3 semester, we ask students to fill in. Okay, fill in means that you need to type inside. If you type wrongly, let's say the answer will be 0000 without space, 0010. It will give the instruction for you. It will give the instruction. Kenapa dia tak nak naik ni? It will give the instruction that is mentioned. Okay, please write answer without any space. So normally we will put space if we are having like 4-bit, isn't it? For us, it easier for us to write down. But sometime in the question is already mentions the hint. Might be give you space in between. Might be mention no space at all. So please make sure while you key in, there is no space at all. Although you have like one space here, your answer is similar. Your answer is similar, but with a space, then you will get wrong. So we don't know. Last time in digitology subject, I already also mentioned to you this kind of question, embedded type of question. If you are lucky, last time like digitology subject, we give you drop down, isn't it? COA subject, we have several experience. We give drop down. Sometimes we ask student to write inside, fill in directly, which is you need to key in. So it's depend on who did the question. Okay, who did the question? So we just follow the majority choice from lecturer. And normally like might be it also will ask you to put in the question is said, if there is empty space, like here should be empty, right? You need to type empty. You cannot type EMPTY. You need to follow exactly. If it is all short form, you need to have all short form. Short form pula. Small letter. Here is a capital letter. If the question asks you to put all capital letter, you need to exactly follow. If not, you're going to get wrong. So that is the things that you need to know. In terms of multiplier, MP, MC, you cannot swap the place. Normally, we will give you this P, MC, MP. We will give you here. So you need to know which one is MP, which one is MC, and which one is P. Similar to your division. Similar to your division, you need to remember and to know there is several things. First of all, related to this flowchart. You need to know how to apply, where you need to know about the remainder more than 0, where is the remainder less than 0. Then, which one is the dividend, which one is the divisor, and which one is the quotient. But all of this in the table is slightly different, isn't it? It's going to be the remainder. So, which one is remainder? So you need to know it is slightly different with the multiplication, which is your remainder for multiplication. Here will be put at this place, isn't it? It will be the remainder. But for division, it will be this one as a reminder here for the first initial value. And your quotient, because it's already mentioned, this is your quotient. Okay, so it will be quotient here, which is 0, 0, 0, 0. But for the multiplier, it will be a reminder for the quotient right side. So you need to remember the step and how to apply between two. Okay, I already asked you to do the example. I just want to see in terms of very simple one for the multiplier. Division, later on we will discuss because we want to directly go to the next subtopic later on. Okay. Ui, ramainya tak buka webcam. Okay, Ikmat. Ui, laju. Janganlah laju-laju. Saya nak cari nama yang terbuka ni. Imran. Imran. Last class, last week, okay, bukan yesterday. Last week, I already asked you to do exercise. And, okay, might be the simpler one, the easiest one, which is, yang mana yang pendek What is similar? Okay, solution. Exercise. Mana dia? Exercise 2.2. 2.2. There is no negative or positive. It must be easier. Imran? Apa itu? Tiba-tiba dia kata slide into my DMs. Siapa baby dekat sini? I don't think there is baby here. You already several times did not open your webcam. Sekejap, macam mana I nak remove lagi? I asyik lupa dia. I nak kick terus because this is not an First time, move to lobby and then remove. Mana nak remove? Remove. Kalau dia masuk lagi, I remove lagi Ahmad Al-Munajid. Where is your mic? Where is your webcam? I malas. I'm too lazy to check my chat. Last time I already informed you that please don't do any things in the chat box. Ahmad Al-Munajid. Please.
Yes, doctor. I'm
Okay.
here.
Please share your screen and solve the solution for 2.2.
Okay, give me some time.
Okay.
Which one? 2.2?
Which one? 2.2? Exercise 2.2.
Okay. Can I solve the next one? Because I'm not ready now. Sorry.
No. We are waiting for you. You need to solve right now because I asked all of you and already informed that I will ask in the class since last week. Maybe you can
Okay.
share your screen and then we can see your solution step by step together.
Okay, I'm sorry. My solution is not ready.
Yeah, I know that it's not ready, but you can share your solution and you can do it directly.
Okay.
Okay. You can share your screen now and then maybe you can open your pen or maybe Jamboard for you to write. Maybe you can just open your PowerPoint.
All right.
Or words. You need to copy the question. Just screenshot the question might be and then fill in.
COA. Okay. Okay, can you see my screen now?
Yeah.
Okay. The exercise in the lab?
Not the lab.
Oh, I'm sorry. Which one do you mean?
Exercise 2.2.
I don't find it here.
Yes, it is not here. It is in the module.
Oh, okay.
You didn't download your module yet?
I downloaded it.
But why you open from e-learning?
Okay, I thought we have exercise now in class, different one. Excel.
You already finished module 1. We are currently at module 2.
Sorry, I'm confused. This one.
Exercise 2.2.
Okay.
2.2.
Mm-hmm.
Okay, this one. You can see there is a solution there. You screenshot first because we need this table. You just need to fill in the table. But there is a two page.
Mm-hmm.
2 pages. One page is only.
Yeah. So do I open an Excel and fill it?
I think not Excel. Maybe you can have Paint,
Word?
Word. Yes, Word can also, if you can like fill in, draw something.
Okay. Okay, we need 5 columns.
You can copy a screenshot. You just screenshot the picture. Later
Okay.
on, you use the option draw at your words. Okay, you screenshot this
Mm-hmm.
and then paste to your words.
Okay.
And then maybe you need the flowchart because you still not remember yet, right?
Right.
You can screenshot the flowchart also and put on top of this question, so then it's easier for you. You can copy also the question related to the value.
This equation?
No, exercise 2.2.
Okay, this is exercise 2.2. Do you mean the equation? Which one?
The question, not equation.
Equation?
Question, yes.
The question, all right.
And then you need another one is flowchart.
Mm-hmm. The flowchart where I get it from? Do you mean from the draw?
No, the module.
Okay.
Last time we already learned the flowchart.
Yes.
It's too far now.
So
It is too far. You need to go back to 2 point what? I guess pages number, what is this page? 48.
48.
Not similar with me, I guess. 48 for the PowerPoint, not in the pages.
Okay. In the pages.
Yeah.
So should I find it or what do I do?
Above,
Okay.
move until you can find 48 above.
This one?
No, this one is division. You need to have a multiplication now. Multiplication, yeah. Below,
Below? Okay.
there is the flowchart there. Here.
This one?
Yes.
The multiplication algorithm. Okay.
Did you attend last class?
Yes.
This one we already go through together.
Okay.
Okay, maybe you need this flowchart and then you can put in the question for you to look into what is the step that you needed.
You mean we need to follow this flowchart to answer this question, right?
Yeah.
Okay. So here we have the multiplier, the value of multiplier.
Maybe you can screenshot first and put here so it's easy
Mhm.
for you to follow the
Okay.
step.
Mhm.
But make it smaller.
Okay.
Above, I think.
Mm.
Beside also can.
I think there is no space. I cannot. I'll try.
Can make it smaller. The flowchart need to be smaller.
Okay. Is it good now?
Yeah. Okay, you need to solve the question.
All right. So first of all, we have these two values. So multiplier 0 will be 510.
It is 5 base 10, not 510.
Sorry, it's 5 what?
5 base 10, 5 decimal.
Like this?
This is
5.
5 decimal. 5 base 10, not 510.
Okay. And the other one is 4.10.
It is 4 base 10, 4 decimal.
Okay. 4 base 10.
Okay, which one is MP, which one is MC, and what is the value of the product? You use the draw, right? Then you can draw.
Mm-hmm. Okay, the multiplier MB is 510. I can write it here.
Where do you put the value? Supposedly, where is the first value, initial value?
Okay, the initial value should be.
Maybe you need to refer to the notes related to which one is MC, which one is MP, and which one is product.
Do you mean the note in the slides here? Okay, doctor. So first of all, I should fill the initial value here.
Initial value will be the first row.
This one.
You can follow and teach. Maybe some of your friend can teach you. Wait, I need to answer the call.
Okay.
Hello.
So can someone help, guys?
Ya, Waalaikumsalam. Ya, saya. Okay. Hmm. Gerangan je kau.
In the first iteration zeros, the first step you need to put initial value.
Okay.
Tak, saya dah minta
I
extend.
put the initial value here, right?
Saya dah
You
minta
already
extend, tapi
okay, nice. And then the 5 base 10 and the 4 base 10 you need to convert into binary.
All right. First of all, the initial
But
value is 1 and 0.
yes. But you need to identify which one is multiplicand and which one is multiplier.
Okay, how to identify?
So in this question, a multiplication of 5 base 10 with 4 base 10. According to the notes given, it says that 5 base 10 should be multiplicand and 4 base 10 should be multiplier.
All right.
So just convert it into according column.
Okay. So it will be the initial value, the first row.
Yeah.
Well, then the 5 base 10 is the
It's the multiplicand.
multiplier. Okay.
Convert it into binary number and write it at the initial
You
value.
must write it
row.
as a binary.
All right. So it's 0.
Here's a tip, man. You can do that with the Windows calculator.
The fuck?
Convert it to a programmer.
All right.
Yeah, and you can write the number that you want. Okay, there's a binary value 0101.
Great. Thanks, man. 0101. Okay. And the other one is 4, which is 0100. Oh my God.
Rather than you.
I think it's also better if you zoom in. Like if you zoom in Word, then try to write.
Yeah, I think so, because it's getting very hard now.
Sorry. Okay. Where are we now?
Okay, we are now writing the initial value. Okay, so this is the multiplier and the multiplicand. And
Okay.
then,
Can you check the multiplicand total bit? I think multiplicand need to be double bit. Might be for MP if it is 4 bit, multiplicand need to be 8 bits. If multiplier is 6 bit, it's going to be 12 bits. Maybe you can see the example last time. Anyone can help your friend related what I mentioned?
Yeah, doctor. I'll help him.
Okay.
okay, please. So,
Okay, so you're just gonna add more bits to the left.
Yeah.
So you can add 4 zeros. On multiplicand, I recommend that you remove all that. Then you try to make your font smaller. No, oh my God.
And at the beginning, you need to put an initial value at the row first. Row, is it called
here,
row, right?
this one.
Yeah, that.
All right. In
That
binary, right?
4 bits. Yeah. Okay, Amira, you can go Sahur. Where are you? Mm.
Wait, not that, man.
MP is 4 bit,
The
MC
multiplier
will
is
be
only for
double.
So
MC
the
is
initial
the
value is going to be in binary.
Yes, all it will be in the binary.
Okay. And this value is correct, right?
I forgot already.
So
MP is what?
it's,
MP is 4 ah?
yeah, 4.
Okay.
For the multiplicand, You're gonna add the 4 zeros to the left.
All right.
Okay, for the rest of you, you need to remember, MC will be double bit. Okay, you can times 2. Times 2 from the MP means that MP is 4 bit, MC will be 8 bit. If MP is 6 bit, you're going to have 12 bits for the MC.
Okay. So now I have to write the value of 5 in
Yeah.
4 bit, right?
8 bits.
8. Okay. So it's gonna be 5 0 1 0 1.
But before that, you're gonna add 4 zeros to the left. To its left. Yes.
Okay. Oh my god.
Are you using the laptop's touchpad actually?
Yeah.
Bruh.
Let me grab the mouse. It's gonna be easier.
Doctor,
Yes.
can I ask a question for a while?
Yeah.
Can I know which question, if the question asks for 4 bits or 6 bit question, and then what shall the answer will be like? How many bits for, like, where we have to apply for 8 bit or 12 bits for the
Okay,
answer?
normally for in the question it will mention how many bits. Maybe you can see example exercise 2.2 is mentioned in 4-bit binary. Isn't it? At the starting, at the question, it mentions 4 bits. So the MP will be 4 bits, but MC will be double from the question mentions. In the question, you can see 2.3, it's mentioned 6 bit. So if 6 bit, the MP will be 6 bit, but MC will be double. Product will be also following the 6 bit. Follow the MC. Product and MC will be follow similar, but MP will stick in the question. Question will mention 4 bits, 5 bits, 6 bit. If you look at your notes, example will be mentioned 4 bit. Example 2.2 is 4 bit. Example 2.3 is 6 bit. So if 6 bit, your MC, your P will be double. Okay? That is only different. In front of it, it's going to be like 0, 0, 0. Unless it is negative, then you need to have 1, 1, 1, 1.
Thank you, Doctor.
Okay.
So now here the product will be in 8 bit.
Yes.
Okay. So first I have to multiply.
No, at the initial value, it is 0.
Here 0.
You're still missing a 0 on the multiplicand as well.
This one here.
Yeah, to the right.
to-
To the right.
You need to have 8 bits.
It's wait. It's 0 1 0 1. So
Hello, Doctor.
yes.
Here.
Yeah.
Alright.
Sorry to say that we are running out of time. So I think maybe the friends who have did the exercise can explain in front of the class because we not finished yet our module 2. So
Yeah.
and we don't did our lab 1. So I think we need to finish our module 2. Sorry, my friend.
Yeah, it's okay. Sure. You're right.
Okay, so you need to learn from this. Next time, whatever I mention in this class, please take note because this one we already do it together. Okay?
All right, doctor. Thank you.
Okay, you can stop sharing now. Okay, for the rest, I can see some of you still not ready yet. We will we will do it together later on, but please make sure you do that first before tomorrow. Tomorrow is Wednesday. Yeah, there is several exercise I mentioned to all of you to do it. For multiplication and division as well. Okay, we already finished until the division. And I mentioned why I want you to do it because it's very important. It is a must question. Okay, that's why I need you to do it. Last time I mentioned most of like might be on the theory part. Let's say for here, for the bias exponent I mentioned, or might be you can spot the question. Might be this one asking you what is the bias exponent and etc. Right? Because you don't know it can come out or not. But the thing is, I already mentioned these two things: multiplier, first division multiplier, and first division. Sorry, what is the name? First, I also already forgot the name. But this one will be coming out. The multiplication, the first version multiplication hardware, first version division hardware will be come out. It is a must question. That's why you need to try. And please do several other question changing the value. And of course, mostly if you are lucky, you will get both positive number. We will give many set for you. Sometimes you get set A, sometimes you get set E, sometimes you get set G. So we will change the value and also whether it is a positive or negative. So if negative, it will be slightly critical because you need to change it using the second complement. If you still remember, so you will be playing around. I give you example last time in class. I mentioned you will having like much slightly higher in terms of a bit number. You're going to have like 1101, 1010. So when you have this, you need to deduct later on with your MC value. 1000, let's say. So this is require your knowledge in your digital logic subject, especially on the numbering system chapter 2, and we did a recap last time in our module 2 for COA subject. So please do it because this is not a spot question. This will be a must to come at the part B. And I already mentioned to you it's going to be occupy many in marks, might be 10 or 12 or might be 10 until 15 marks, just this kind of question. So make sure don't wait until your test, because if you wait, there is several other question that also require your knowledge more. You need to focus more, so it's hard for you to do. So it's better for you to do in class, and maybe after directly after the class finish, you need to do. Okay, so we need to proceed. We need to proceed with our next. We done the fixed number. I already mentioned fixed number is not too hard for you, especially when you are knowing about the first complement, second complements, because all is slightly similar to digital logic. But just that things which is the first version multiplier and divisions is new things for you. That's why I want you to focus more. Next, we want to look into the floating point. If you still remember, floating point is after your radic to the right. The fixed number or digit will be your left. This one we already cover. Now we want to look into the floating point. In terms of representation component, Normalize, unnormalize. This one is a favorite question. You will be given with the numbers and you will be asked to do the normalization. There will be several ways for you to normalize. Standard, normal, normalize, but sometimes it mentions about the IEEE. There is also a normalize. It is different. So we need to focus. There is several normalization, two normalization, but it is depend on normal normalization and IEEE normalization. It will mention in question, okay? Okay, this one you can read by yourself. Now we look into directly on the representation. When you have your number, this one you familiar, it is a normal integer. But for this is your floating number. When you have to the right after your ready points. And you can also represent this number in terms of scientific notation. Okay, this is the things that later on you're going to see in terms of normalized or unnormalized. Okay, here you're going to see in terms of the component. This is just a representation. You can represent like this, you can represent like this. It is just show you how you can have the possibility to have the floating point numbers in terms of the normal numbering that you are using and in terms of scientific notation. Now we have the component. We have, sometimes we can have the decimal number. This one is binary. I hope that you still remember. But in the floating point, last time in decimal, you have 5 base 10, 101 base 2. This is your best number, decimal, binary. You can see it here. But in terms of floating point, in a scientific notation, what is this number? This is decimal. If you have multiply with 2, means that this is binary or base 2. Okay. In terms of integer, might be you can have 101 base 2. Okay. But in floating point, maybe you can have 0.001 times 2. It will be a base 2 also. This is binary. Let's say I give you an example in terms of octal. Maybe you can have 2, 3, 4 times 8. The power of 10 might be. So this one, is going to be a floating point. 2 might be. So this is a floating numbers in terms of scientific, but you can see it component is, this one is octal. Okay. Let's we look directly. Okay, this one you can see there is a sign here. We call is a significant fractions or mantissa. This is also favorite question for the MCQ. You were given with the value and the question just asks you, what is the mantissa for this value? If you don't know what is mantissa, maybe you can pick this to be a mantissa. Maybe you can just pick this. So you need to familiar with this because there is 3 terms. It can be also said, what is the fraction value for this number? So you need to know, okay, this is the fraction. And what is the base? What is the radix? So you need to know where is it. Okay. This will be coming out for the MCQ question might be 1 marks, might be 2 marks, but it's very simple and very direct question. And another one is exponent. This one, it's very easy. I know that this is exponent for the whole mathematical when you start learn from your, I think, secondary school. You know that this is the exponent. Okay. Fraction and exponent, fraction or mantissa or significant, can be positive or negative. You need to put the value in the question. Okay, now you know the basic things on the floating point, how it can be represented, and also what is the component. You need to know the name. This sign, this is 3 terms that you can use. This is 2 terms that you can use, whether it is base or radix, and also your exponent. Now let's take a look in the standard, normalized and unnormalized. You were given with the value. You just need to pick whether it is a normalized or unnormalized. That is also can be asked, and this is a normal and favorite question for the test 1. Okay. And as mentioned, normalized thing can will be having 2. First is normal standard, when the question just ask you to normalize. Mana question dia tak bagi. Okay. Might be store the decimal number 17 in this model. So you need to do the normalized thing, and there is no at all mentions about IEEE. So you need to follow these normalized things, which is this side. Because later on for IEEE, this step is different, but the name is similar. Normalized. Okay. For now, it is not IEEE. It is a normal standard. What you need to do is to normalize it, you need to have 0 in front. And after the radic point, it will be non-zero. But later on in IEEE, it will be different. You need to have an in front value. It will be something, which is later on you will see there will be a different. But stick in your mind first. This is for normal standard. For normalization, after your radic point, it will be non-zero. Okay, after your radic point, it will be non-zero. But if it is unnormalized, after the perpuluhan, the radic point here is going to be 0. So it's easy for you. You can see here, it is unnormalized. Why? Because after the radic point, it is 0. It is normalized because after the radic point, it is 1, which is non-zero. Here, after the radic point, it is 0, means unnormalized. After the radic point, it is 1, which is, it can be 2, 3, 4, 5, 6, 7. It will be normalized because it is non-zero. Okay, so you need to stick in your mind first. This is a normal standard. Normalization process. If you were given, okay, you know the standard now. But if you were given with the numbers like this, you need to know this is unnormalized. But you need to know how to do and change it to be normalized. You need to move the radic point, isn't it? You can move, might be you can move to here. You can move to here, but when you are moving the radic point, it's going to affect your exponent value. This is normal mathematics. So I hope that you easy for you to understand, because this is a normal mathematical from your secondary school. You already learn how to move the radic point and also the value. Now, the normalization process. Normalization is process of deleting zeros until non-zeros value is detected. So you need to check before this number. Is there any zero? If you have zero, you move. If you have zero, you move until you meet non-zero number. Okay? You need to check at the left side first, because for normalization, normally your number will be start on zero, with zero first. Okay, if you here, you need to move to the right. How many times you move? Alhamdulillah. Now you're going to move 2 times to the right. You move 2 times to the right. That's why when you move to the right, you need to minus. When you move to the left, you're going to add. Okay, that's rule you need to remember, and this is just a normal mathematical. To the right, you're going to deduct. Okay, so you move to 1, 2. You find non-zero. Then your number will be 0.743 times 10 to the power of 4. But you move 2 times, which is to the right, minus 2. Your answer will be 0.743 times 10 to the power of 2. This in terms of normalized. From the unnormalized number. Second example is 45.09. As mentioned, you need to look on the left first, because this is the floating point. You're going to start with 0 first on the left. That's why you're going to meet 0 first and then radic point. But you cannot move to the right 0, 9, because at the left side you have another number, isn't it? So you need to move to the left. 1, still you have a number here. You need to move to the left. Now you didn't have a number which is starting from 0. Then it's okay. 0 point. You have a number non-zero here. That will be okay. How many? 1, 2. To the left. So you're going to have 10 to the power of 4 plus 2. Your answer will be 0.4509 times 10 to the power of 6. Then it is a normalized. So sometimes you were given with this value, you need to be normalize it to pick the ABC, which one is correct. But sometimes you begin the given with the several numbers, you need to pick which one is normalized or which one is unnormalized. There is several other example. Let's say like this. If you have a numbers non-zero in front, what you need to do? You need to go to the left, right? 1, 2, 3 until you meet 0 there. And beside the radic point, there is a number. Okay. Number what? Non-zero. Okay, 0 in front, non-zero after your radic. How many times you go and to move to the left? 1, 2, 3. You times plus with 3. So you will get the answer. And it is also similar. The step is similar whether it is decimal, whether it's binary. What is best number? It's also similar step. And 10, 20. Okay. Then you can see here, this is another example. This is unnormalized number. What you need to do, you need to meet 0 first. So you need to move the number. Where you going to move? 1, 2. At the left, after the radix, it is non-zero. And here is 0. Then it's going to be the normalized. So how many? 1, 2 plus 2. This is normal mathematical, but you need to be aware this is binary. You need to convert to decimal first. But you can also convert plus 2 to binary to follow this. You can write this in terms of binary. You can also write this in terms of decimal. Oh, there is no example. Okay, like this, at the bottom side. That's why you have a choose. You can write in the binary. You can also write in the decimal. You can represent exponent as decimal. That's why you can change this to decimal first, plus 2, or might be you can change the plus 2 to binary. But which one you prefer, which one is you familiar, and you can use it both, okay? As long as your answer is similar, which is correct for you to normalize it. And then for this part, this is 0, 0, 0, 0. 1, 2, 3. 3 times you find this non-zero. This is 0. To the left of your radix, right is non-zero. Then it is this is normalized. How many times? 3 times. To the left, it means to the right, negative. You need to deduct 3 times. So you just deduct 8. This is in terms of decimal. You can change it also to the binary. Okay. For any question before you move to slightly confused, because there will be, see, IEEE normalization. This is IEEE normalization. Later on, you're going to see slightly different. Okay. So for this normal standard number, without mention any question in the question part, IEEE, so you need to use this normalization. Okay. I have plenty time. Let me check my phone first. Wait, I'm afraid they call me. Okay, they still did not doctor article. Okay, let me touch a bit about a format, a simple model. Before we move to IEEE normalization, I think we're not going to cover that today. We look into the format first. A simple model. In terms of your digital number computer, floating number consists of 3 parts. Sign. This can be also what? Mantessa. What else? Magnitude. Fraction. And you're going to have exponent and base also here, right? So the general form of normalized floating point is like this, which is similar to the ones that you just learned. You have this positive, negative value sign. You have the normalized number starting from 0. After that will be non-zero, and you're going to have base and exponent. Okay. then this is the format. But you need to know also how this format number, example 0.11 times 2 base exponent 2, power of 2 maybe. Okay, how you can convert this number to the binary form? How you want to convert this normalized floating point format to the binary form? So you need to remember this format, because in the question you were given with just a value 0.783 might be times 10 to the power of 3. You need to represent this and pick A, B, C. Which one is the correct format of binary form? So you need to know the sign is in front. If your numbers is positive, negative, what is the sign? You need to remember back. 1 bit. 1 bit is not value 1, okay? If 1 is negative, isn't it? If positive, it will be 0. Okay, 1 bit means that you only have one space. One space for 1 bit, the value. You can have update version. And exponent here. How many bit? Later on you will be given how many bit for the exponent. It's depend on your model, okay? But you need to know where is the place first. Exponent. After that is going to be a sign bit again and your fractions or Mendesa. This one is the bit. Okay, you're going to have normally your bits number like 32 bits, 64 bits, isn't it? Normally your normal number. So there is several format. If you have example, if it is 14 bits, how many bits that you're going to have? So this one is in terms of format. We will look into deeper later on, okay? I don't want you to confuse, especially as mentioned, there is two way for do the normalization. Stick first in your mind, this is a normal normalization, not the IEEE. So you need to understand how, and when you are playing around with this IEEE model, later on and above, you're going to follow the rules of IEEE normalization. It's slightly different, okay? You can try to look into how, and later on there will be a lot of equation. So it is not going to be bored, because last time you just look into theory. It's very boring, very sleepy one. But when you are playing around with equation, with the formats, with the number, I guess it's slightly interesting. Before class, maybe you can try to do some recap first, and you can answer understand this clearly, okay? So maybe you can compare between these two things, normalized, standard normal, and also IEEE normalization. What is the lecturer mentioned? What is the difference between these two, okay? Tomorrow we're going to proceed with this simple model and above, but please make sure do the exercise for 2.3 until 2.6, I think, because before we start our class, we need to do it together. I hope that you already have all the solution, so we can speed up and we will continue. And make sure you can run example or template that given for the Visual Studio. Try to run, because normally you will find error. Don't wait until your lab 1, okay? Don't wait until your lab 1. It's going to be after after or before your module 3 to do the lab 1. But if you have the problem, it always happen to your previous semester, your senior, they will sometime until the end of semester also they cannot solve the error. So that's why you need to start from now, okay? For those who in the UTM, if you want to use the lab computer, might be you cannot install things in your computer, you can use and request me. I will inform the coordinator for the subject to give you a permission to use computer at School of Computing lab, okay? Might be after this also, when after Raya, you can directly do your lab at the lab, so it's no need for you to install later on. But for now, lab 1 to 3, I think you need to do it using your own machines, okay? Any other question? So I just give the QR code for those who attend this morning session. 39 student. Ada orang tambah lah. I hope that you didn't pass the picture to your friend because I start late today. So next class, please make sure you come and attend the class earlier, okay? Any other question?
Miss,
Yes?
might I ask you to review the answer for 2.2 in the group WhatsApp?
Give answer.
As there's two type of answer there. How to see if both of them are right or wrong.
You are discussing in class, okay.
Yeah, in the group WhatsApp, yeah.
I didn't check answer. 20? To answer. If they're already in. What is the difference? I just see the answer, last answer.
The MP MC is swapped.
Oh, okay.
Yeah.
Okay. As mentioned earlier, if positive number, there is no problem at all when you swap.
Okay.
Normally, it's not problem at all because you're not going to use a second complement. When you are playing a second complement, it will be like 1, 1, 1, 1 in front, right? So it will be slightly different, especially it's going to affect your value of P later on. Okay? But when it is positive for both, normally it's not going to be a problem. Only that, normally in our initial value, MP or MC will be given. Only the product you need to select. But might be in initial, normally will be given the value. Okay? So you know which one is MP, which one is MC.
Alright, thank you, Miss.
Okay, so you can try to do negative number. You can check what is happened. Okay, later on in term of the answer. Beginning in the question, I already mentioned this one is easy because it's both is positive. You can do directly the question. Okay, any other question? Okay, if no question, I need to go. I have a presentation today. Actually, it's already start at 9:30. But my turn, I think, might be I'm a 12 person. Yeah, 12. So it will be like about 10. But I need to prepare first in the meeting. So we meet again tomorrow. I hope that all of you will try because it's very important, okay, for you to try the first version multiplier and divisions. Thank you and meet again tomorrow. Bye-bye.
Good luck, Doctor.
Okay.
Thank you, Doctor.
Thank you.
Thank you, Doctor.